Jarad is the CTO of Humanoid, and they just landed last year and they're doing insanely well and extremely fast. So they've gone from design to prototype in 5 months, which is kind of insane for the humanoid space. And he was at Brain Corp before this, and then iRobot, where he's seen it all. And he scaled like millions of robots, for example. And with Stephen, he is the founder of Neuracore, CEO and founder of Neuracore. They just raised their pre-seed, 3 million, which is amazing. He's been in an industry, he's done research, he was at Dyson, he was at Berkeley, he's at Imperial. He's an assistant professor, he leads FOL, so he's the entire robotics stack in one person. So between both of them, we have all of robotics in a way. And so like they actually know what's happening right now and what works, what doesn't work, and where things are going. So like this will be a natural conversation. We'll try asking interesting questions. Feel free to pitch in, and then we'll have some food. Right? Sounds good? Okay. So let's begin. And thanks to 50Y for letting us host this, and I'll pass it over to Steph, who's going to tell you more.
Hey everyone, so great to have everyone sitting here today inside this building. I'll start by giving you guys a quick intro to who we are to contextualize this rather bizarre but very cool building we're sitting in the middle of London. We are 50 years. We're a pre-seed and seed stage venture capital firm who exists to help civilizationally important founders. What we're incredibly passionate about is helping people at the earliest stage of their journey to work out, is founding for them? How can they build the most impactful companies? What is the best way possible for you to maximize your impact and achieve the vision you want to see the world become? To do this, we run a program called 50/50, where we support incredible technical people to explore that journey. They come in a variety of different stages. They might already have ideas, might already be working on projects, have IP, or might be at the earliest stage and just realize that actually they want to have an impact with what they're doing. And then we give them that entrepreneurial wraparound for 3 months, part-time, so it can be alongside academic commitments or work commitments. Or if they're already full-time building, then we help to just make sure they have a space they can come to right here with us each and every day to work and build and push forward. We would absolutely love to tell you more about what we do. So we'll leave a few QR codes bouncing around the house for you guys to find, and please come chat to me if that sounds interesting. We have to give a massive shout out for being able to run 50/50 here in the UK to ARIA, the Advanced Research and Inventions Agency, who powers us and makes the magic happen. They also have a robotics dexterity program. They're just like us, incredibly passionate about robots. So go and check it out. And we would really love to get more people working robotics into our next cohort. So we'd love to chat more about that. One of our partners who runs the program with us, he works the mentor every single week, found a company called Vicarious, one of the earliest AGIX hardware companies in the space. He raised 250 million, exited to Alphabet, and incredibly passionate, as we all are, about helping next generation. If that sounds interesting, come chat. But with that, I'm super excited to hear from our great panel. So thanks so much, panel.
So this is my,
So that's very stable.
So like you can't talk about robotics without talking about data, right? So let's actually start with data. And so from where you guys sit right now, what do you think is the actual bottleneck? Is it the amount of data we have? Is it how we use data, how we collect data? Just give us an idea to just start the conversation.
First off,
Yeah, sure.
So I think it depends on what you're trying to do, right? So if you have an application in mind that is not necessarily falls into the category of general purpose robots, then we already have, I think, the majority of the algorithms that we need, and I think we probably pretty much have the data that we need for or if we don't, you can go and collect it, right? I think so I think we have everything we need in that case, right? And of course you have a skilled team around you to do that. If you're going down the realm of more general purpose robots, then of course the amount of data that you need is kind of a crazy amount, right? It's actually kind of unfathomable. And I think there's been a lot of hype in the field recently, kind of mostly driven probably by like language models, right, and how successful they've been, right? And it is mind-blowing, right? I still can't get over every single day. I feel like I'm a magician with like how much I'm able to do with it. But I think we kind of just forget like how much data has been trained, right? How much data we use to train these, right? We're very actually bad as humans visualizing numbers once they get like really, really big. And so like 3 billion sounds, not that too much more than like, I don't know, 3 trillion or something, right? But it's actually like a huge difference. So I think we forget just how much data basically these language models are trained on. And robot data is just so much harder to get. It's so much harder. And it'd be like trying to get people to sit in a warehouse somewhere and write out all of human history that's ever happened down on paper and then give that to a model. Like, because that's what ChatGPT has been trained on. It should be trained on the entirety of things that have ever been written and documented. And we're trying to do that for robotics, right? So
is that possible? Can you do that?
I don't think so. I think we're going to have to turn to simulation. It's going to be a mix, right? And it's going to be a common theme for me at least, right? Is that you've got multiple tools in the job for the job, and in robotics we need everything that we can get, literally. So like simulation data and real data.
What do you think, Jarad?
Yeah, I think I would mimic most of the things you said there, right? So like I am like terminally online, so like I see like a lot of the conversation points that come up, and like is this autonomous vehicles all over again? Like, hey, we got a hint of something, and like, it's going to take another 10 years to actually get a product out there, which by the way, like autonomous vehicles are actually happening now. I don't know, like I've spent probably 15 hours in a Waymo now. Before I moved over here, my Tesla was driving me to work with 0 interventions. It was like a 12-mile trip both ways with a freeway, side roads, crossing railroad tracks, etc. Like, this stuff is actually starting to work, but I really don't think robotics is like autonomous driving, depending on what you're trying to do with your product. So like, at our company, we're going into industrial use cases. These are semi-structured environments. These are like very repeatable use cases over and over again. I'm not trying to zero shot walking into this environment and try to figure out how to navigate around or clean up this room or do something like that. I think there's a lot of companies that are aspiring to get there. I think that's a lot farther off than the use cases that we're going after right now. So like what we're finding, and what I imagine others who are playing around with these models have found, is like it actually doesn't take that much data right now to get the models to a reliability that is enabling you to demonstrate to a potential customer like how this will look. Right? It's still not nearly at the pace that a human's going to be able to do it. It's not with the like range of what a human would be able to do. But for like fairly narrow, repeatable tasks, which a lot of tasks right now in different environments that people would pay for, you can actually pull those off with either UMI style data, which you've probably seen. I mean, everybody likes to draw data triangles now, or data pyramids. Like, our base is UMI data, so we collect quite a bit of it. It works. You can train models entirely on UMI data and transfer it over to robots, and it works. Now, would you deploy that? Absolutely not. But like, conceptually, you can see that it works. And if if some of you don't know what a UMI device is, it's a gripper that you hand hold. So a human can hold a gripper, and from the perspective of the wrist-mounted cameras on those grippers, it looks like it's being operated by a robot. And so that's kind of like the base. That's not even necessary. Like, you can skip right over that. You can literally just get the middle tier, which is what is the exact use case that you're trying to perform, teleop the robot to perform that task. That's it. And it really doesn't take that much, like 20 to 30 examples, like 50 to 60. You can start demonstrating it. It's by no means reliable enough that you would ever deploy this into a customer location, but like 400, 500, 600 demonstrations. If you have nothing else in the mixture, it actually works. And that's pretty crazy. So I agree. To be able to like go generalize to anything, that's pretty far away off. I think simulation could be part of that path. You know, the dexterous manipulation modeling in sim is still not there. Super contact rich. Dexterous manipulation is not there. Deformable objects not yet there. But there's a lot of investment going in here. And then there's of course world models, which, you know, initially I was looking extremely skeptically at. They look really great right now. I'm not convinced I can trust any of the physics coming out of them. And so they may have a role to play in evaluating models. But if you really can get to the level where they are, you know, faster than real time, and with probably a lot more sim data being used as ground truth, I could imagine them being actually a better backbone for these types of models that companies are using than what we're using today. Because VLMs, they're kind of a weird fit as like the actual backbone of a VLA as an example.
Like you guys mentioned sim quite a bit, right? What percentage of the data that you use at Humanoid is sim? Because you have 600 hours or something, and
Yeah.
what is the split?
Yeah.
So like, do you use sim at all?
None of that is sim.
Okay.
So we've trained in sim for the locomotion policies
Yeah.
and for the body controllers. So for training the robot to walk, sim works fantastic. And we really went from, we assembled the robot, and 2 days later it was walking. And then if some of you have seen the video, like that was filmed like a week after.
Yeah.
And so people are like, why isn't it running yet? It's like, literally it's been a week. Like,
It's
my,
running.
my marketing team's like, go fast. So like, yeah, all the engineers were like, this is impossible, there's no way. Because we have a lot of traditional controls people at the company as well. And people from Boston Dynamics and people from Sanctuary and Agility and Optimus and so forth. And those people coming from that more traditional paradigm, they saw that gap be 6 months. You know, you assemble the robot, you fine tune all the different solvers for many different months, and like we just blew right past that. RL in sim absolutely works for locomotion.
Is that a good way to think about sim in the sense they're really good for movement, but as long as you like move more towards manipulation, it's going to become harder and harder?
Yeah, I mean, I think I don't know why my
Like I want to mention like Sergey Levine put out a blog saying like he's
Yeah.
really big all in on real data.
Yeah.
And he believes that if you're going to have models operating in a certain domain like the real world, they need to mostly be trained on in the real world.
Yeah, and he's super bullish on that, and I mean it. And I've been in physical intelligence's office, and like, yeah, they get a whole lot of data collection. So,
Hundreds.
yeah, I mean, I think again, it's what's the objective of the company, and like, what kind of use cases are you going after? Right now, I don't see the need for sim for the use cases that we're going after. I would love for sim to work. It could be a nice, very scalable approach, but I would say it's not there yet for the use cases that we're going after.
And Stephen, like Neuracore, right? A lot of people use your platform to collect data. So are you seeing a bias towards like simulation data, or what's the split on your platform? How are people using it, like academics, researchers?
So
What are they doing?
definitely more the real world side, and the reason being that if you are training on sim these days, 99% of the time actually you're training on policy, so you're like just training with the data as you generate it, so there's no need to actually like collect the data and store it. If you're doing completely off policy, then yes, there's a need for it, but no, like the majority of people who use Neuracore are doing it because they have real data and they just want to go like, I've got my robot shipped to me, whether I've built it or wherever I bought it, and I just want to now get it to do something awesome in the real world as quickly as possible. And the best way, quickest way to do that is still to collect data in the real world.
And do you think sim is better for RL because you can like have success detectors, you can kind of discreetly say what is successful and what's not? So do you think that's a path people can go and take?
I mean, I can talk absolutely hours about sim. So like, basically, I'll just try and give you the short version. Yeah, so like, I've gone back and forth basically. So I started my kind of career in robotics basically with sim to real. Like that was my very first ever paper, like the first ever Coral was in sim to real. So like domain randomization wasn't really a thing then, it was just starting to become a thing. Our paper was the first to ever do like visual domain randomization for imitation learning, right? So it's like we were right at the very, very beginning of all of this. And so naturally I was very big on sim, and I was like, this is the future, this is great. And I had a few different then iterations of this, so very, very big. I think what dawned on me though was someone has to build the simulation environments.
Yeah.
And that's kind of the hurdle that you hit. It's like, oh my God, great, I've built this world, I've built this kitchen, and now I can have infinite data from it, which is true, and that's awesome, right? And you can actually do sim to real transfer, even with vision actually, quite well, and get it to fit well to this kitchen. But that's just one kitchen, right? And what we need is many, 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 right? And so someone has to go and build those. So that was then the realization that I came to then, is that it's like, this is not scalable. And actually, if I'm going to spend a lot of money and a lot of time building these simulation environments, and then I have to deal with the sim to real gap on top of that, I'm better off just going to the kitchen, just collecting it. And it's going to take a fraction of the time. That's the realization I had, and I still think it's valid. I've slightly changed my mind simply because of language models, or VLMs in particular. Like, if we can now take a picture of a kitchen and get it to generate me a URDF or an XML Majoko file of that kitchen, then I think that's awesome, right? Mind-blowing, right? Because then you can actually have infinite data. So I've slightly changed my mind that maybe the only way to do this is sim, but I still think this is the way you do it for a general purpose robot. Like if you've got a domain and you know a lot of the stuff, you might as well just do real, to be honest. Yeah.
But what I want to push on like manipulation. Do you think is there something fundamental about it that's hard to simulate, or do you think it's like maybe 5 to 10 years from now we might get there?
I think that another thing to mention here is like Locomotion obviously is incredible, like all of this stuff is trained in sim, but you've got to remember most of them are blind, almost all of them are blind. And secondly, you can shape rewards so easily, right, with Locomotion tasks, right? If the robot falls over, then obviously that's a bad thing, and it's a good thing to stay straight and with these velocities, etc., etc.
And this is for RL.
This is for RL, right? Yeah. So training these Locomotion policies with RL and sim, you can shape things very, very easily. With manipulation, you can't do that easily, right? Because every task is so different. You've only got so many tasks, right? With Locomotion, stand, run, squat, and then a few others, right? Core skills. Yes, thank you. But with manipulation, there's so many tasks that we do, right? And then you have to basically shape a reward for each of these, which is obviously very expensive and very hard, and a terrible thing to do actually, because then it's like not optimal. And so then we're back to, well, demonstrations. Okay, let's bootstrap then the process with some sim demonstrations. But if I have to now build my simulation world, and then not only that, I have to then make a demonstration in this simulation world, like using a human, but controlling a sim thing. Again, maybe I'm just better off taking my robot and learning.
Just like concretely, we have a simulation team, of course, because there is stuff we do in sim, and we have, we wanted to A/B the, what if I replicate this physical twin digitally and create the digital twin out of it, and then what if I actually just collect the data in the real world? And time again, it took us longer to get the sim tuned well, versus like, we literally just collected the data, we trained the model, we evaluated it, and it was like, okay,
Exactly.
just to reinforce that.
Oh yeah.
Even with like fairly narrow use cases, it was hard for us to move faster in sim than just collecting the data in the real world.
And maybe just one more question on data. So like, if you look at text, right, it's extremely dense, semantically rich data. But then you take videos, it's almost like the information is not a lot, density-wise. So you actually need a lot more video to get the same output that you would get from some text. And so do you think this is a problem eventually, as you go down the line? Like, how do you close this gap? Or do you have to close this gap? Is it important?
Maybe I'm misunderstanding, but if
Yeah.
I would disagree with that. I mean,
Okay.
wasn't the saying a picture's worth 1,000 words,
Mhm.
right? So I think that there's way more information in the picture than there is in text.
Okay.
But also like if you think about a video that's 30 FPS, between the frames, there's not much change happening.
Yeah.
Uh-huh.
And so if you think in terms of tokens, you could say It's probably a lot of tokens per frame, but between frames, you could. Some people have even put up this. You can approximate it to 1 token per frame because not a lot is changing, right?
Yeah.
So that makes it super hard. And then going back to self-driving, it was in some cases easier because there was like humans driving cars was useful enough, and companies like Tesla could just make use of that. But with robots, like we keep having to pay people to generate data. There's like people setting up warehouses where persons like just folding clothes all day long.
Yeah.
How are we going to close the gap?
Yeah, I think it's what's the objective. So like, yeah, with self-driving, you have to work in every scenario you come across, right? With a robot, a logistics robot moving totes, or like doing a machine feeding task, which is like something somebody literally does all day, right? Like we're setting up warehouses, but like literally someone will stand in front of a tote that has bearings in it for 8 hours a day and just do this. That should be automated. And so like, yeah, exactly. So like collecting that data is actually doesn't take that long, and performing that task reliably is easy. In self-driving though, like, I don't know, I've actually never driven in the UK, but I've seen lots of crazy stuff in California. So like, yeah, I mean, one of my first weeks living in California, I moved from the Northeast to California. I saw a car reversing on the freeway, and I was like, okay. So like, yeah, I mean, lots of crazy stuff is going to happen, and you need that to all be in distribution. And like, while there's going to be weird things that happen in these warehouse environments. It's not, it's not a literal life or death situation. If we just need to stop the robot and say, I don't know how to recover from this weird scenario I'm in right now. So in that narrow way, I think we have a path, and this is like really what I'm focused on right now, and the company's focused on right now. But like, yeah, pure zero shot, go into any environment. I don't purport to know the recipe for that.
And since you mentioned self-driving, right? We had these crazy demos like 15 years ago. And it took 15 years for something to come to the market that's actually being used. And I think it's similar with humanoids now, where we have all these cool demos. When do you think these demos become real products? Like, what is the timeline in your head?
Yeah.
And because
Next
you're
year.
actually doing this stuff.
Like I genuinely mean it. Now we don't have we have 2 product lines. One has a wheelbase.
Yeah.
One has legs. This is kind of the boring stuff, but when you start to scale robots, like when you actually try and go sell into a customer, right? They want to see that you have some sort of credibility as an organization, that your product's safe, it's reliable, their data is going to be handled safely. It's not as flashy as all the RL research or VLA stuff, but like this really, really matters. And so at my past company, we ended up deploying 40,000 robots in public spaces. So in the US, in every Walmart, there's a large floor scrubbing robot, and it works in public, and your child can run up to it and it will stop safely. And so that type of engineering is the same approach that we're taking with the wheelbase system. And so there are safety standards, and this is where, I don't know, I might lose the crowd, but there's A, B, and C type safety standards. And A is the most broad, is like, your thing shouldn't light on fire. And C is the most specific, like there's literally a checklist you need to follow. And for like wheel-based robots, there are checklists. And so it's still complicated, it still takes a bunch of expertise, but like there is a recipe for deploying wheel-based systems. There's hundreds of thousands, millions of AMRs deployed globally. So we're using those standards. So like from a safe navigation standpoint, we know how to do that. And if you use these models to then be able to perform these like narrow tasks in environments, like that's gonna get fielded next year. Bipeds is a different story. There is no type C standard for bipeds, there's no type B standard for bipeds, there's only type A. And this will slow down adoption into industrial environments because they can't guarantee they won't fall. And so the way some of the bipeds get deployed right now is they get deployed in work cells. But trying to have a customer modify their environment to support this robot kind of defeats the purpose of a humanoid in the first place. So I know there's a lot of interesting work going on here. There are Type C standards that are being worked on, but that's going to take many years to get through the regulatory bodies. We have people working on those standards. But yeah, so I think the gap, like, if you can call our wheelbase robot a humanoid, which I do, then it's next year. If it's a bipedal one, then I think it's a little bit farther off, just because of these kind of like very real friction points that they're going to run into trying to deploy them. Now, if you're Elon Musk and you own your factories, you can just deploy them.
How do you see their competition? Because they have the capital, they have all the supply chain, they have everything, right?
I take Elon Musk extremely seriously. I would never doubt that guy. Sure, like, is he gonna put 10,000 out this year like he said at the beginning of the year? Probably not. There's 5 days left or whatever. So, but like, yeah, he's a force to be reckoned with. Like, for sure, I expect they're gonna figure this out, and they're gonna be able. I just assume they're gonna be their own first customer. I just also don't think this is like some sort of winner takes all dynamic where Tesla, makes some progress and then clear, like, everybody pack it up, go home. I'll shut down all your businesses. Like, no. So yeah, I take them seriously, but I don't think it deters what we're doing at all.
And speaking of competitors, how do you think about your competitors in China, where like they seem to have hardware advantage built in, where they've got Unitree and many other electric vehicle companies are now sort of directing their attention to humanoids. And then they also have like really good models like DeepSeek, Alibaba, and so many others. So there's like both of them coming together.
Yeah.
And how do you? Why isn't it the case that they will win by default?
Yeah. Super good question. Yeah, they are doing amazing work in China. I'm not like one of these like we have to beat China. Yeah, China's like a world superpower. They're gonna do great. So yeah, I mean, there's a couple of reasons. One is, so I worked at iRobot. iRobot had factories in China and literally nobody cared. And then I went to Brain, and some of the products we made early on were made in China and nobody cared. And then sometime people started to care. And then they started asking like, what, is your robot made in China? No. Okay, what components come from China? I'm like, where do you care? Like, if the steel comes from China, do you care? If it's the sensors, do you care? Like, where do you draw the line? They're like, genuinely, we don't know. Yeah. They're like, then why are you asking me this question? So, yeah, I think geopolitically things are shifting. And so I do think you're probably going to get, I don't know that it's going to be full-blown like this sovereign AI concept that's been going around, but I do think you're going to get something like that in the robotics space. DJI, the drone maker, they were kind of borderline whether or not they were going to get banned in the US because they are a dual-use technology, right? Do you want millions of drones in your environment that may be remotely controlled by a foreign government? So I think there's going to be something like that, and there are going to be these friction points where, even just for geopolitical reasons, there may be these limitations on importing tens of thousands, hundreds of thousands, and certainly millions of humanoids from even different geos, not even necessarily just China.
Yeah.
So I think that is just like one kind of like very real world reason. But otherwise I think it's going to look kind of like the automotive industry. This is my mental model at least. It's like, I don't think there's one robot that does literally everything. In every, like, there are very huge humans, there are small humans, there are big work trucks, there are small commuter cars. And so I think you're going to see that, right? So like our robot is like a large industrial workhorse meant for working in industrial environments, and you're going to get very small ones, and I think you will have kind of almost national brands to a degree, right?
Yeah, maybe now we can jump to a few company specific questions.
Okay.
So we can start with Neuracore, right? You guys use your platform to connect data, and people annotate data, like they do a lot of stuff. Do you see a path, like somewhere in the future, where you can use this data to make your own foundation model? Because, like, you can essentially do that, right?
Never.
Never? Okay.
No. So that's not really what we do, and so. The data that's uploaded is our customers' data, it's not our data. right? So it's like we take that very seriously. So we use the data to like help improve the platform experience, right? But ultimately, we are there to help companies move quicker, right? So if you're a robotics company, we want you to be able to start one, even if you're not even in the field, and then be able to get up and running with another robotics company that's maybe been around like for 2 years within like, you know, a month or something. That's the goal of the company, to help companies move quicker. And yeah, like we are in the process of building that trust, and yeah, we're not there to make our own foundation model, right? The only way we'd make a foundation model, I think, would be then to use the open source data that we host, because we also host a bunch of open source data. And there are companies we speak to which are like data collection companies, which you may have seen a lot of recently. Yeah. You probably have seen a lot, every day. So yeah, but yeah, so they're very much interested in like open sourcing some of their data, right? So they can be like, hey, look at this cool data set, and then come and buy the rest of it. So yeah, we could use that data, but ultimately no, that's not our main goal. Is just to make foundation models.
Okay.
And Jarad, what about you guys? Like, are you following the figure or the Tesla strategy of you're gonna make everything in-house, including the models, or and also in terms of the models, is there domains that you're focusing on? Because when it comes to humanoid, they're not really saying are they going for the home, are they going for the factory?
We're very much going after industrial, manufacturing, automotive, retail, but all on the fulfillment center side or warehouses, so forth. So that's very much the domain we're going after. The aspiration is to go after homes longer term, but as I've said a bunch of times, I think that's much farther off. On the model front, we've used open source models quite successfully, but we are also pre-training our own. And basically, part of this is just a difference of what is the objective of the models that are out and openly available right now, and then what is our company's objective, right? So like, at Physical Intelligence, they're trying to make a model that works on basically all robots. We have 2 robots. We have a very specific set of use cases we care about. Cross-embodiment does seem to help. So it's not that these generalist or specialist generalist models, after you fine-tune them in a certain direction, doesn't help, but like, is their objective to be able to run 30 FPS at the edge on the compute we have? Not necessarily. And so, yeah, we are training our own models to be optimized for the hardware we have in the use cases that we're going after. And then you could go down the list, right? There's like DeepMind, who has their own objective, very similar, right? Another research organization trying to go after like general robotics and so forth. And so yeah, this is why ultimately we use them as a benchmark. It's great that they exist. I also worry about having my company success depend on the generosity of these other companies to like do all the pre-training for us and keep riding their latest models. But yeah, I'm certainly speaking with all these folks to stay close to what the actual plan is there.
Okay, makes sense.
And one more thing is you have 2 form factors, right? You have the bipedal, and then you also have the what's the other one?
The wheelbase.
The wheelbase.
Yeah.
And if you look at factories right now, like the throughput you can get from a wheelbase is insane.
Yeah.
Like, why would someone go and use a wheelbase with hands when they can get maybe 10 times faster throughput from like classical?
Especially designed for
Yes.
You said a wheelbase with hands? You
Like
mean
with arms.
okay, not a biped.
No.
Okay, so you're asking like why
Legs, I think.
Yeah.
why legs? What's the core of your question?
No, the core is like why that form factor. So like,
Yeah.
when you see legs fitting in that situation.
Okay,
Um,
legs specific. Sorry, I misinterpreted what you were saying. So yeah, the wheelbase is the one that we're commercializing. There are series type A, B, and C standards.
Yeah.
There's a direct path. So like, direct path is to go commercialize that thing. On the biped's for service in homes. That's much longer term, as I've mentioned. That biped's way too big to go into homes. The one we have is basically like opportunistically built as a research platform, because all the other ones, right, like G1s are awesome. You know, they fall down, they don't break, they can dance, and their payload capacity is almost nothing. So like to actually lift something, there's just not good third-party hardware if you want to be able to like move heavy objects around. And by heavy, I mean like more than a full Coke can.
What's the payload capacity?
I don't know what they officially advertise, but in my experience, once you add an end effector, you know, it's on the order of, okay, and now I'm in the UK, so kilograms, not pounds. Well, you guys do pounds too, it's weird world over.
I think it's about a kilo-ish.
Yeah, it's like a kilo and a half. And so, yeah, our robot has a 15 kilogram bimanual payload. So you can lift a lot more with that system. But yeah, I mean, I fully agree. Our customers want wheel-based systems. Our customers use wheel-based systems. I've deployed lots of wheel-based systems. You know how to make them safe. It works. And then, you know, Brad Porter, who's the CEO of Cobot, he scaled Amazon's fleet of what was originally Kiva, and now, you know, there are many different flavors of it, to 1 million robots at Amazon, and he doubles down on this too, right? Like a lot of these places design intentionally to be traversed by wheels, whether that's autonomous or it's people pushing trolleys and carts and so forth. So that is why we're going with the wheelbase. It's like, to me, direct path to commercialize that.
Like that's your like timeline for the next, like you're
Yeah.
focusing everything.
Yeah, when I say next year, it's that system.
Okay.
Like the end of next year is when we're gonna bring our more production intense systems online. What you've seen so far were the prototypes. Like, how do you rush to a prototype to put in customer sites? Basically the goal was get it 80, this is like to my engineering team, we gotta get this 80 to 85% correct. We're not gonna get this perfect, but like we gotta go fast to go get it in the market, to go figure out what we got wrong, so that we can change that for the production intent design, and then take that to mass manufacturing.
Yeah, and let's see, where do you think, how will Neuracore be useful once you get to ARIA?
So once I think that most people will,
Yes.
yeah. So yeah, that's exactly why we are in the works with our aspect as well. So right now a lot of our focus is on imitation learning.
Yeah.
For reasons I've already said, it's kind of like simpler, it works like well, and actually a lot of the people we speak to, you know, aren't the general purpose companies, right? I mean, there's not that many that can afford to do this, something like this. And so, and then also there's a lot of people who just don't think it's going to work anytime soon, right? Which, you know, I agree with, right? So we actually work with companies that are much more kind of like, they have a problem and they're actually trying to solve that problem with a robot, and they know exactly what the domain is and, you know, the conditions, etc. So imitation learning is fine for them. Having said that, we do know that the future is going to be RL. So like a lot of the tools of how we built our stack supports then RL, and like, you know, naturally, we're just, there needs to be some tweaks that we're making.
So you have that in mind?
Oh,
Yeah,
I mean,
that's good.
it's,
Yeah.
yeah, I live and breathe RL
Yeah.
basically, and every day that I go into work, I'm just like, oh, why aren't we doing RL yet? So, it can't come soon enough, basically. So, yeah, and ultimately, you know, we it's not just a platform, right, that we're building as well. We're also building like a community. I think it's important to understand.
Yes.
Like Neuracore is, it's literally, it's one and the same of a commercial product for enterprise as well as a product for academia, well, not even a product, free for academia. That's another thing I haven't mentioned. It's free actually for institutions around the world. So if you're not in our kind of whitelist, just you can click a button and then you get added to a list, and then eventually you'll be added in. And we care deeply about basically building a community around robot learning, right? And such that people can iterate incredibly fast on their research ideas. That's why we've open sourced all of our algorithms. So everything that's like in the platform from an algorithmic perspective is all out there and can be built upon. So yeah, super important, and RL will be there soon as well.
So there's actually your platform benefits these researchers, these students at universities, right? Because
Yeah.
you've made that free now for everybody.
Yeah.
How, like, apart from community, how do they help your platform in return? Is there like a technical thing that you get back from them?
So how do they help us?
Yes.
So I guess it's about this community aspect, right? So they I guess help us by helping maintain and build that community, right? So the idea is that like once you release a paper, right, you've got a new fancy new, I don't know, extension to an imitation learning algorithm you've released. And the metric of success, of course, for a PhD student is people using my work, right? It goes beyond citations, so it's like, I see my work being used, right? That brings PhD students a lot of joy, right? So the best way to get that to happen, of course, is to get that code out there and in a usable format. Neuracore is designed to be like enterprise production grade, like algorithms, right? That you can just like plug in and work on any sensor, any input and any output, right? And so they give back to, I guess, us then by helping others in the community, whether they're companies, right, or whether they're other researchers. So it's a nice little cycle. Like we provide the foundations, we provide the infrastructure, we help them like build their algorithm, and then they give back by then sticking that algorithm in, which is probably already open source anyway, and then helping us rather than us going and like bringing it in ourselves, they do it themselves.
So it's like a flywheel.
Yeah. It's an algorithm flywheel, and also data, by the way, as well. So of course, we house all of this data, we host their data for free. So if some PhD student has collected, I don't know, 10,000 hours of robot data, or PhD students, then they have somewhere to host that data for free. Whereas otherwise they'd have to be like, oh, PI, please can you spend some money to like host this on Google or something. So, yeah.
That's interesting.
Yeah.
So I think we're running short of time. I'm just gonna check real quick. Oh, perfect. Maybe we can open the floor to some questions from the audience. And before we do that, do you guys have anything to add from your side? Maybe something we missed, maybe something you find interesting?
I'll just quickly add, I was answering your question earlier about what the company should focus on if their customers are robotics companies. I think that was your question. I did not mean to crush anybody's dreams. If your customers are not robotics companies, because I think there's a lot of stuff you can do in the robotics space. If you're trying to sell to consumers or businesses and so forth. So specifically my answer was about selling to robotics companies.
Okay. So let's start. Okay, from there.
Sure. I really enjoyed the talk, guys. I wanted to ask a question about, like, I've seen this business model kind of emerge. Companies like 1X and Robotics and to some extent Waymo, of like building the robot, deploying it in the real world, doing remote teleoperation to gather data, but also to kind of like have immediate deployment, and then kind of using that to eventually train autonomy. I was wondering what you thought of kind of like this business model. Is it the near-term future of general purpose robotics? And yeah, just asking for general thoughts.
So, I guess so. Just to reiterate the question, I guess it's like you build the hardware and then you figure out autonomy later, right?
Exactly. You teleoperate to get
Yeah.
training data.
I mean, we're into speculation land here, so I would say I don't get it. I don't buy it. I would say, if I'm going to be honest, like, who is going to let some strange person into their home which is going to be teleoperating? It's going to be like super early adopters, right? Pretty much, which is a very, 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 very narrow distribution of people in the world. Those early adopters are probably going to be very wealthy as well, so they can have very different houses. And you're just going to get just this weird skewed distribution. And they're probably going to do weird stuff with the robot, come on. let's be honest. If you're that type of person to like, sign up to this and I don't know, I just think there's just going to be some strange stuff happening. So I don't buy it basically. I think it's great. I think they'll learn a lot. I think they'll learn a lot from it. Like the effort, I think the effort's great that they're doing this. Like the fact that they can go about it, but I don't see it as a scalable model. Yeah, I think there needs to be another level.
I think it could buy time, and
From a funding perspective.
yeah.
Well, yeah, of course. They're probably forced to do it, I guess.
Yeah, I think a lot of them are going to raise a lot of money.
Yeah.
And then they're going to have the benefit of time while the research, marches on. And I think you're exactly right with the model, but I think it will probably be, if you look at the Tesla Roadster model, they sold 2,200-ish Roadsters, and they were super expensive. They were like $250,000 in 2007 dollars. And but that's a lot of money.
That's very different as well. Like, it's
Yeah.
not just about the money aspect, right?
Yeah, but I also think in the Bay Area, people would buy. I think people would buy Neo if it could only do this, because it would be the coolest thing. There's a lot of very wealthy people up there, but it could do even more than that, right? Honestly, I was surprised at how cheap they're planning on.
Yeah.
Putting it out
That
there
is,
for.
that is surprising.
10,000, right?
Yeah.
I also feel like you could have an Uber type situation where like each teleoperator has a profile with stars. So if someone does something weird, we'll
I think that's a really cool, like, you're right, like, I don't have an Alexa in my house, I don't have a Google Home, like, I don't have any of these things that listen to me besides my cell phone. But there's a lot of people that will, even if it's just thousands, that's a good foothold if you just do the math out on how much revenue they could potentially make there.
Sorry, can I ask a follow-up question on that? Sorry.
Can we
Oh yeah, sure.
quickly switch? Because
No problem. Yeah.
Or maybe, yes?
Me?
I think
Yeah.
this is
Yeah. Sorry. So what do you think about the world model? Right? Does it play a role next to simulation and real data?
I'll try and be very brief because I think I can talk a lot about this as well. Yes, I think it's going to be huge, basically. Yeah, yes. I cannot say more than that. Like, it's the future.
Is it a data collection paradigm, or is it replacing real to sim to real, or is it something in between?
I think it's everything. I mean, even as simple as just like evaluation, right? Like being able to like train your models using, let's say, whether it's imitation learning or reinforcement learning actually, and then just have a way of being like, how good is this actually going to be without me actually running a robot? Like, that's something we still don't really know unless you've got a simulation environment, of course, which if you're training on real data, you do not. So, yeah, even off the bat, I think that, just evaluation is very powerful. And actually, you can already do quite a lot with some of these world models for evaluation and get an indication perhaps of how good something's going to be. In terms of like for using it for training, I still think we've got some ways to go, but they are getting very, very good. And all you really need is kind of more robot data in the mix. Because I don't know if you've tried any of them like recently. Sorry?
Marble?
Any of them really. Like they all kind of suck on robot data. But if you can fine tune them like a bit, then they do quite well. Right? Work has shown this actually in the community. So I think that maybe all of that data that everyone's collecting and spending a lot of money on should be going towards training the world models rather than actually training the actual policies.
Interesting.
Maybe we can do one here and then back there.
I'm interested if you think reinforcement learning means the end of useful annotation through demonstrations, because it seems to me like if you look at how LLMs progressed, it was reinforcement learning combined with human feedback that was the key unlock. And do you feel like reinforcement learning necessarily means the end of this paradigm where we need to collect thousands of hours of robot demonstrations?
No. So I actually, although I've done a lot of reinforcement learning, anytime you actually talk to me and I say the word reinforcement learning, it actually is always synonymous with demo-driven reinforcement learning. You look at any of my work, and actually nothing is ever not demo-driven. So it's like, take some demos to give like the robot an idea of what you're trying to do. So you're not shaping a robot, just saying, go in this area and play over here, right? And then that's very powerful, and you basically need that, because otherwise you'll never accidentally succeed at the task. So yes, 100%.
Yeah.
Demos aren't going away. It's just I think the way that we use them will be very different.
Back there.
Thank you so much for the talk, really insightful. I'm a security researcher, and I've been thinking about the implications of having, let's say, 50 million humanoid robots in our homes. And if someone hijacks that, you can use it to physically restrain someone. Are you guys thinking about the impact of this, having all those things in our homes and then using that as a attack vector?
And maybe let you start with it.
Sure. I think it is a serious question that needs to be answered. So like, I think about it in layers. So one is device security. So I've fielded robots in the past where you have like something like Trust Zone, which you may be familiar with, and full disk encryption, right? So this like prevents, full disk encryption is basically preventing anybody from exfiltrating the data off of your hard drive, even if they got physical access to it. And secure boot is basically a set of technologies starting at a hardware root of trust to ensure that the software that's running on the robot has been certified by somebody else. Presumably the company that manufactures the robots and does the software for them. So those are kind of like two key like cryptographically sound technologies that I think at least will ensure that the thing is running what you expect it to. And then typically what you have is like a separate safety processor. And that safety processor will have safety certified code on it. And you can go through NRTLs, which are nationally recognized testing laboratories, that will do the certification for you to say your robot is safe in XYZ scenarios, right? And we have tested it to some degree. This is back to my boring safety standards, A, B, and C's, to be able to certify that your robot will do a safe behavior in these different environments. So I think we're not worried about this at this stage. We're working on full disk encryption, we're working on secure boot, we have a separate safety processor, but basically the attack vector of our type of robot is not our robots in all of your homes, but I imagine the solution is something in that direction where there are key technologies that you will be expected to adopt, and you will have a separate safety processor that will be able to intervene if the system is starting to do something that it shouldn't be doing, even if it's being instructed by a human, right? Like you can imagine like a human teleoperator embodying your humanoid robot and telling it like, oh, go do this thing with a sharp pointy thing. And somewhere in the safety processor, I think there's, and we're a little bit far off from this right now, which is back to why I'm not sure that the bipeds are ready to get deployed. Like, in case you don't know, bipeds fall. There will be some sort of AI-based human detection, and then what are the behaviors that the robot needs to perform when it detects a human? Like the safest answer right now is literally you go into like a defensive low kinematic mode, where you like get down, which is kind of like weird dynamic-wise, like socially, I mean. So I think there's a lot of research that has to be there, but I don't think it's like this hopeless, what are we going to do? All of our robots are going to get hacked.
Just a follow-up iteration for that. So we are Zumosay, and we are security researchers in robotics, and we are working on a secure boot system which you can run AI on it, and we're using transformer models to learn robotic anomalies, and we run multiple like UR5 robotics and different kind of even we using simulations on humanoids now, collecting data, and running through multiple iterations of transform models to find out anomalies, and trying to put them into like to find out specifics on how the robot's behavior is changing, and provide them a fail-safe layer, then automatically create a kind of a final stage defense system. Guys, you watch everything, right? Like all the Skynets are, all the movies like fast robots can kill us. They're all coming. So here are the company we envision ourselves. We're trying to create a chip, like a secure system, which like you can't predict that. Imagine the robot is so many layers, like in cybersecurity sector, the most important thing is triangle, confidentiality, integrity, and availability. The problem is, imagine a system like a robot is like a network within network, and if that network and the whole system is compromised, who are you going to trust that system? That's the final question. You can't put 100% on it. So then you need to have that. We think as a startup that the external secure system should be independent, and they should be run through a different set of AI, which can detect anomalies within it and make sure robots not killing each other, like killing humans or going rogue. So we're actually working on it, and I have a small demo downstairs. I can show you how it works. And
fantastic.
Come have a look.
My quick follow-up question with this is:
Can we actually jump to Thor, because we've been going back and
just my question is mostly how we validate the systems that we build on top of learning and creating standards out of this. That's my main the background of my question, if this is something that you want to comment, especially for humanoids or deployable robots in the wild or in industrial.
How are we validating the performance of the models?
Based on standards, you know, like safety standards, you've trained your world model or you've trained your policies, and on top of that, you have to prove that it will work.
Yeah.
Because in space, we do it all the time. So that's why you cannot deploy AI in space, because at least at the point that it takes decisions, it has autonomy and all this stuff. So for now, you're not allowed to do that because you cannot prove it will work. But do you see this coming as a problem?
I mean, the standards that we need to comply to are around safety. So like, how do you perform safely around humans? So that is fairly well understood, which is separate from how do I know that I'm going to pick up the tote reliably all day. So yeah, I think it comes, just to be succinct, like for us, it comes back to the Type C safety standards that around making sure no humans get harmed as part of our robots navigating around the space. I think I probably don't have a thoughtful enough answer to the.
But this is only about navigation. It's also you pick something and you pick someone. I mean, you know that this is
no,
not
it's a good
happen.
question. I mean, like you're probably familiar with this, right? You have to go through the HARAs, the like hazard and risk assessments, right? And like there are always these like kind of like almost comical like chain of failures that you could imagine, but then you have to weigh it against like what is the likelihood that that actually happens. And so yeah, I mean our robots, the biggest risk is the robots like fall on somebody or they just don't stop. And so like there are very specific ways to test and design the system to ensure that that doesn't happen, like fail-safe ways. Yeah, we're working with the major NRTLs to make sure we do that right. Yeah.
Okay, we can do 2 more questions, guys. Actually, at the back. Yeah.
We are a data services company from India, so we are legit selling shards to people like you. However, we run a lot of experiments in-house, and one of the recent experiments we started is collecting failure demonstrations. So we are, setting up tables and asking people to sort of training people to knock over bottles and water-filled glasses. But we want to understand. How far do you think this sort of demonstrations would be included in training VLAs? Because as far as I understand, very few experiments rely on using negative loss terms.
You mean just failures?
I mean, success cases, but the complementary failure cases.
Got it, okay. So like dagger style recovery episodes, or?
I think just failure, right?
I mean, both of them. I mean, like you pick a bottle like this and then you pick it up along the side so it topples over.
Mm-hmm. I'm not the head of AI at my company, unfortunately.
Maybe I can answer that one. So it only works if you're using RL, I would say. so you'll do very well once the RL reckoning comes.
One last question, guys. Who should I take? Okay.
Thank you for
Sorry.
tonight's very insightful. Sorry. I'm also a PhD student in robotics. I have I did internship on humanoid, like motion retargeting and reinforcement learning training, this locomotion policy. And currently I'm doing VLA policies, like training VLA with IL. To be honest, I'm very disappointed in both those 2 hypes. One is humanoid, one is VLA. I don't think they will make huge breakthrough. Mm-hmm. One is because I'm proactively follow like the latest papers published in those 2 areas. 90% of humanoid, like those authors are trying to make humanoid dance better. Mm-hmm. And like 90% of VLA papers, they're just change different ways to overfit to their demonstrations. Yeah. And they claim, okay, our models are sorted. Yeah. And like those companies, either humanoid and VLA, this company like physical intelligence or Google DeepMind, they show different skills but I believe it's also kind of overfitting if you check the models inside. Like they have those like unknown keys which somehow defined by those demonstrations. But I think like those demos raised like this raised expectation of the public, or they think, okay, like maybe after 1 or 2 years we can realize AGI in robotics, but I don't believe.
Yeah.
So my one question is, do you think those are bubbles like AI? And the second question, from a PhD student perspective,
yeah.
What really lacks in research area about really pushing robotics to acquire those generalizable skills? So I'm a firm supporter for IL.
Yeah.
So you're like so you somehow so one of my questions I supposed to pose this night, but I think even with IL in VOA, people just make IL to better overfit some demonstrations. We didn't see any generalizable skills from the performance.
So there's a lot to unpack there, but I think it's a good question. So first of all, VLAs. Yes, you're right. They are pretty useless right now. Do I think that it will work with enough data? Yes. I think there's enough evidence to show that. But the question is there a path to get enough data? Now, if you're a company that is building one of these, of course the answer is going to be yes, because it has to be. I don't know if objectively it is though, right? I think that the key question is that you have to just be able to get ChatGPT amount of data in robotics, right, for this to work. Another thing I really want to stress here, and this is to everyone, right, is that VLA is not end-to-end robotics, right? I think that's another really important thing to clarify, because time and time again, I'll have discussions and people will think that we've only just started doing end-to-end, but we've been doing it for over a decade, right? These things have been working quite well in specific scenarios for a very long time, right? And so I think they work well, right? And so they scale well as well to the problem domain you care about, and they are fine with the amount of data we have actually, right? It's just VLA has become very, very trendy and has almost just become synonymous now with end-to-end learning. Okay, so that's the first part I would say. And the second part about RL, I think it kind of boils down to maybe what's missing ultimately, perhaps, I think the question. Yeah. And I would say that for me, the biggest turn-off for a lot of companies and a lot of people is that the sample inefficiency. And so something I've been deeply passionate about for the last 6 years is just sample efficient reinforcement learning, right? Or again, when I say reinforcement learning, I mean demo driven, right? So how can you have an algorithm that just is very, very good at ingesting that just couple of demonstrations and then be really efficient at then learning online with rewards, basically. So I think that's what's missing. So if you're a researcher in RL, that's where I would encourage to work in, is how can you better utilize demonstrations and learn value functions off of them, and then use that to bootstrap your learning process to be just as efficient as behavior planning.
Yeah, that's I'm also trying to look into.
Yeah, fantastic.
Thank you.
Just say.
I'm hiring PhDs. Well, I guess you're already doing it.
Let's say overfitting is not bad if there's a very specific use case that a customer is willing to pay you to solve. So yeah.
Can we call it here? Well, okay. Thank you, guys. Thank you, guys. Any questions? They're around for some time. We have some food downstairs. Just keep the office clean because they've kept it very clean. So just try and keep everything back in place and it should be good. Thank you so much. Thank you so much.